All right, ladies and gentlemen, I'm going to do my best to get through this. Hopefully I can. Didn't want to let you down, so here we go. Problem set 9.2. First question is right here. Do you jog? So we have a random sample. Sample size is 1540. And we're supposing that we know the parameter to be 15%. All right, question A. Find the mean and standard deviation of the proportion of p hat of the sample who jog. Okay. So the mean of p hat is equal to p. Okay, and this is on our formula sheet right here. When our random variable is p hat, these are the formulas we'll be using. Okay, so in this case, we would say it's 0.15. And again, that's the mean of the sampling distribution. So sometimes we'll get less, sometimes we'll get more. But as long as we're doing an unbiased random sample, that should be the average. All right, let's find the standard deviation. Okay, so here's our formula. Okay. And there you go. Put that in your calculator. Should get a decimal, and it should be approximately this. Okay, that was part A. All right, part B. Explain why you can use the formula for the standard deviation in this setting. Hold on just a second. Sorry about that. All right, where were we? Explain why we can use the formula for the standard deviation. Okay, well, this is our 10 times n rule of thumb. So in this case, n is 1,540, and we're talking about joggers. And there are at least 15,400 joggers, so it's safe to use our standard deviation formula. So we're going to expect you to do this without being prompted to do it, right? Again, this is the first homework problem from the problem set, so they're kind of holding your hand, guiding you through. But on the test, I would expect you to just do this before you use your formula that we already did use, by the way. Okay, and that's the way it'll be on the AP exam on a free response question. All right, letter C, check that you can use the normal approximation. Okay, this goes back to chapter 8, remember? N times P, is that at least 10? And is N times the complement at least 10, right? If we fulfill these, then we have something that's approximately normal. So in this case, we have 1,540 times 0.15 and 1,540 times 0.85. Okay, both of these expected counts are well above 10, so we should be safe using a normal approximation. All right, letter D, find the probability that between 13 and 17% of our sample are jog. So this is, now we're talking about the sample. We're not talking about the parameter, right? The parameter is 15%. So what we're gonna do here is a center section problem using a normal distribution, because we just cleared that that would be safe to do. You could, of course, be more accurate and use a binomial distribution here, but like I said, the problem is leading you through to use the normal, because that's why they just ask question C, so that's why I'm going to do it with the normal. Okay, so we want to find the probability that we're between 0.13 and 0.17. Okay, convert to z-scores. And I'm going to write the whole formula out, because if you round these things too much, you can end up being off by quite a bit. So it's better off to just do the whole thing. Okay, and there we go. So work this out in your calculator to get your z-scores. You should get this. Okay. Oh, and notice it doesn't matter if you do less than or equal to or less than when you're dealing with the z-score, right? Because we're talking about a continuous distribution. Normal distribution is continuous. If we were doing this as a binomial, then I'd read the problem more carefully and try to figure out if the boundaries are included or excluded from the answer. All right, so find the probability for this. It's quite large, right? We've gone more than 2 standard deviations in either direction, so we should be capturing more than 95% of the distribution. And if we work this out, sure enough, we get over 97% of the distribution within 2 percentage points. Okay. All right. Letter E, what sample size would be required to reduce the standard deviation of the sample proportion to 1/3? Okay. You can use the formula, right? But you can also realize, again, we have the square root of n in the denominator. So if I want that after I square root it to be 1/3, I just need to multiply by 9. So that's what I would do. But you could plug the info in here, right? And put, you know, less than or equal to whatever, but why bother, right? They're, again, purposefully asking this question because if you know what you're doing, you can just do that. 13,860 for N. There we go. All right, one down. Hopefully I can keep this up. All right, 26. Again, we're continuing with the 15% as our supposed parameter. All right, so now they're saying, what if we changed our sample sizes? Okay, so just redo our calculation, but we're going to be changing our sample sizes. So sample size of 200. Okay. So all we're doing is just changing this number right here to 200. Okay. Oh, and we need to confirm that 200 times 0.15 is at least 10. So let's just confirm that real fast. Sure enough. Okay. So it is safe to use our normal distribution here. So again, both counts, both expected counts, expected successes and failures are at least 10. So we may use a normal approximation. Okay, so let's do it. Probability that we are within, oops, sorry, that's p hat there. Okay, convert to z-scores. Okay, so there you go. Work out those z-scores. I don't have that one worked out yet, so. Okay, so there we go. Okay, and work out that. You could use your table or your normal CDF. But notice we're not even going one full standard deviation here in either direction. So this should work out to be about 57%, much lower. And that's the whole point. Again, that's the point of the problem. Shouldn't be surprising. By having a much smaller sample size, we're going to have much more variation from one sample to the next. And it's going to be a lot more common to get samples that are 2% off the mark. Okay. Then repeat the problem with 800 in the denominator and 3200 in the denominator. So I'll just do that on the calculator real quick for you. Oh, that didn't work. All right. 3.58 for 800. Okay, so this is n equal to 800. Same work as above, just change the 200 to 800. And we will get a much higher probability, right? Because the larger sample size is going to cut down on our variation, and it's going to be much less likely to find things that are more than 2% off the mark. Okay? And then repeat one more time for 3,200. So for 3,200, we get a z-score of 3.17. Okay, and obviously that's capturing a really large chunk of the distribution, namely about over 99%. There you go. Okay, so of course, that's how things behave. As long as you have your parameter inside the interval, as your sample size increases, you're going to get a stronger and stronger probability. Okay. Now, if your parameter is outside the window, then as your sample size increases, you'll get a smaller probability. All right, next problem. Okay, so we have a sample size of 2,500. Okay, all U.S. residents aged 18 and over, so we are safe to use our standard deviation formula, right? So there are at least 25,000 U.S. Is it residents or residents aged 18 and over, so we are safe to use our standard deviation formula. Okay, notice the question I don't think prompted that. We just had to know to do that because it's just part of what we do to validate our work. It's part of our work. All right, suppose that in fact 60% would agree. So they just said, let's pretend that the parameter is 0.6. Okay, what is the probability that 1,520 or more of the sample agree? So this is a binomial question. They really haven't specified that you have to do a normal approximation. So if you want to do a binomial, that would be fine. It would actually be more accurate. But kind of the point here, again, is to practice the whole normal approximation thing. So I'm going to do it that way, even though it's less accurate. So again, we're going to do n times p, n times 1 minus p. Make sure that they're both at least 10. And normally I would do stuff like that in my head, but right now my brain's not working too well, so you'll have to excuse the slowness. All right, so both of those are at least 10. So normal approximation should be reasonable. Both expected counts are at least 10, so we may assume an approximately normal distribution. Okay. All right, now we're able to actually do the question. What's the probability that 150 or more agree? Okay, so not 150 more, 1,520 or more. I was like, 150, that's too low. Very small. Okay. So we're going to find the probability that p hat is at least this. Okay. So again, we said we could use the normal distribution, so let's get a z. Okay. So our z-score should be 0.8165, and that gives a p-value of approximately 0.2071. Okay. Again, that's using the normal approximation, right? If you want to, go ahead and use the binomial CDF in your calculator. Make sure you realize this is a greater than, right? This is a right tail, and the binomial CDF in your calculator is less than or equal to. So if you wanted to do the binomial CDF, you would do 1 minus the probability that x is less than or equal to 1519, right? Because 1520 should be included in the answer. And that's something a lot of us messed up on chapter 8 as far as the boundaries. Okay, so you could do that. And if you do that, you should get this answer. And you can see this is approximately correct. That's why it's called an approximation. All right, 28. According to a market research firm, 52% of all residential telephone numbers in Los Angeles are unlisted. There you go. I'm going to start by recording that. Okay, telephone sales firm uses random digit dialing equipment that dials residential numbers at random, whether or not they are listed. The firm calls 500 numbers in Los Angeles. Okay. What are the mean and standard deviation? All right. Of the proportion. So the mean of p hat is equal to p. Okay. Now to calculate the standard deviation, we do need to say there are at least 5,000 telephone numbers in Los Angeles. So it is safe to use the standard deviation formula. Okay, so let's do it. And we should get a standard deviation of approximately 0.02234. Okay, that was the part A. Part B. It's probability that at least half of the numbers dialed are unlisted. And look at this. Remember to check that you can use the normal approximation. Okay, so here we go. N times P, N times 1 minus P. So we've got okay, again, both these counts are at least 10. So it's safe to assume an approximately normal distribution. Okay. All right, now let's actually do the problem. What's the probability that at least half are unlisted? So we want to know the probability that P hat is at least half. All right, well, they pretty much held our hand again, telling us to use a normal approximation. So let's do it. Okay, work that out, and we should get a z-score. Negative 0.8951, and that's going to give us a probability of approximately 0.8159, which shouldn't be a surprise, right? Most of the time we should be getting 52%. So if we say 50% or more, we should be grabbing more than half of that distribution. All right, 29. Multiple choice tests. Simple probability model for multiple choice. Suppose that a student has probability P of correctly answering a question chosen at random. A good student has a higher P than a poor student. The correctness of an answer to any specific question doesn't depend on other questions. So we have independence. Test contains N questions. And the proportion of correct answers that a student gives is a sample proportion P hat from an SRS of size N drawn from a population proportion P. All right, question A. Julie is a good student for whom P is 0.75. Find the probability that Julie scores 70% or lower on a 100-question test. So we're given P. We're given N. So again, they're going to want you to use the normal approximation, so let's go down that road, shall we? Step 1. Oops. Well, I'll just say 10 times 100 equals 1,000. And we can say there are more than 1,000 multiple choice questions questions. Right. I think they used the word universe somewhere. Yeah, in the universe of possible questions. So it is safe to use the standard deviation formula. Okay, now for the normality. N times P, N times 1 minus P. So this is 100 times 0.75, 100 times 0.25. Okay, both of these expected counts are at least 10. So we may assume an approximately normal distribution of p hat. Yeah, I've been kind of lazy on that. You really should say normal distribution of whatever it is you're measuring, right? All right. So what's the probability she scores 70% or lower? So again, we're going to get a z-score. Okay, so work that out. We should find a z-score of and that gives me a p-value of approximately 0.1241. Okay. Again, you could have used the binomial distribution and had gotten a perfectly accurate answer, but they're purposefully trying to make you practice the normal distribution a lot because we're going to use that a lot coming up shortly. Okay, a couple more. If the test contains 250 questions, what's the probability Julie will score 70% or lower? Okay. This is more questions, but we still pass our checks. Feel free to redo them. I'm starting to struggle a bit here, so I'm going to just trust you to do them. So, p hat. Get our z-score. Okay, so we're going to get much smaller variation here because of the increased sample size. So now we have a z-score of negative 1.826 and a p-value of approximately 0.0339. Okay. Again, you can use binomial if you want higher accuracy. Okay, letter C. How many questions must the test contain in order to reduce the standard deviation to 1/4? Okay, 1/4. So remember, square root of n is in the denominator. So if I want to be dividing it by 4, I'm going to have to multiply my denominator by 16. Okay, were we talking about the original Oh yeah, 100 item test, there it is. So. Okay, so 1,600 questions would have to be used. And I'm looking at the answers in the book. The answers in the book say 400. I know I'm not feeling well and my brain isn't working too well, but I think that's a typo. If you quadruple it, you'll only be cutting your standard deviation in half. So you gotta multiply it by 6 if you want to cut the standard deviation to 1/4. Okay, and that's the thing. There are typos in these answer keys. They're not created by the publisher of the textbook, and even if they were, there'd be typos. So don't worry about it. It happens. All right, letter D. Laura is a weaker student who has a chance of 60%. Does the answer you gave in C for the standard deviation of Julie's scores apply to Laura's as well? Oh, excellent question. And of course, yes. So Laura will have a different starting standard deviation, but if you want to divide it by 4, you're going to have to multiply n by 16. So, yes. And again, you can elaborate. Okay, see if I can get through this last one. Rules of thumb. Explain why you cannot use the methods of this section to find the following. Letter A. A factory employs 3,000 unionized workers, of whom 30% are Hispanic. The 15-member union executive committee contains 3 Hispanics. What would be the probability of 3 or fewer Hispanics if the executive committee were chosen at random? Okay, so here's the problem. 30% of 15 is not a large enough number. Okay. Remember, we have to have at least 10 expected successes and at least 10 expected failures. 30% of 15 is not 10. It's 4.5. So we fail that requirement. So there are not at least 10 expected successes, so a normal approximation cannot be safely used. There we go. That was easy. Letter B. The university is concerned about the academic standing of its intercollegiate athletes. Study committee chooses an SRS of 50 of 316 athletes to interview in detail. Suppose that in fact 40% of the athletes have been told by coaches to neglect their studies on at least one occasion. What is the probability that at least 15 in the sample are among this group? Okay, so 10 times 50 exceeds the population size, so it is not safe to use our standard deviation formula. Oops, 500, since the population only contains what was it, 316? It is not safe to use the standard deviation formula. And letter C. Use what you learned in Chapter 8 to find the probability described in Part A. Okay, so that means binomial, right? Okay, so we want the probability that x is less than or equal to 3. And we had, let's see, n was 15, p was 0.3. Okay. I guess we should state binomial. All right. And this, by the way, is what's going to happen on the AP exam. There's going to be times when you can't use the normal approximation. So you just have to know, hey, I failed these requirements, but I can still do the problem. And not only that, I can do it more accurately using binomial. Okay, so this is the probability that x equals 0 plus the probability x equals 1 plus ... probability x equals 3. I guess I could have put 2 in there. Didn't save that much. All right, so we've got 15, choose 0, 0.3 to the 0, 0.7 to the 15, plus 15, choose 1. Some of you on your Chapter 8 test didn't change this number, okay? Realize this number is changing because now we want 1 from the pool, okay? This was 0 from the pool. Now we want 1. So there's 15 ways. It could be the first or the second or the third or the fourth, right? All the way out to the 15th chosen. That's why this is 15. And then the last one, 15, choose 3, 0.3 cubed, 0.7 to the 12th. So there's my work. Then you go ahead and use your binomial CDF. So remember, CDF is a less than or equal to, so we're good to go. We can just jam in 3 right in there, and we'll get our answer. And apparently the answer should be... Okay. I'm just copying that from the answer key, assuming that it doesn't have a typo. All right, guys, there you go. I'm going to go take a nap. Thanks for tuning in.